Okay, so you're going to cut on just the dotted lines, so it should be like this. These should be flaps. You've got flaps on the sides, and then these are flaps as well. So it takes a little bit of time, but just cut those out on the dotted line. And then you're going to take your second page that looks like this, and we are going to glue the second page into our notebooks, and then we are going to glue it onto the notebook, and then we're going to glue the page that we just cut out on top of it so that when we open those flaps, you can see the table underneath it. Okay, so pause the video and do that at this time, and then we'll continue. Okay, so when we talk about exponents, we are talking about the different rules that go along with exponents. So the first rule is the product rule. And the product rule, turn this flat back. What is the product rule? The product rule is if you have two powers with the same base. So let's just use variables. So x to the a power times x to the b power equals, if the base is the same, you can leave your base and you can add your exponents. So it would be like this. Okay, and we'll do an example down at the bottom. What is the quotient rule? The quotient rule is similar to the product rule, but we're talking about division instead of multiplication. So if we are dividing two powers with the same base, that's an A, then we're going to subtract those exponents. And yes, sometimes that may give you a negative exponent. That's okay, we'll talk about those in a second. What is the power rule? This one is a little bit different from the product rule because this is, what if I have one base and it's raised to a power like this, and then we raise it to another power, so an exponent of an exponent essentially. In this case, just like with regular parentheses, parentheses means multiply, same thing here, A times B, okay? Now we are going to do the negative exponent rule and the zero exponent rule. For negative exponents, it's kind of like we don't divide by fractions, we multiply by the reciprocal. For negative exponents, the power that has the negative exponent, we take the reciprocal of that, and the exponent becomes positive, okay? So if it were the other way around, if it were 1 over x to the negative a power, the reciprocal would be x to the a power. So you take the reciprocal and make the power, make the exponent a positive power. For zero exponents, anything to the zero power is 1. And we are going to prove that down at the bottom in that table. So anything to the zero power equals 1. Very easy to remember. And then we'll prove it down at the bottom, okay? All right, let's look at the side pieces. Solve the following: 6 to the negative 2 power times 6 to the 5th power. Now, forget about the fact for a second that this is a negative exponent. The first thing we want to do is the actual work. So we want to use our product rule that said that if we have the same base, we add the exponents. So we're going to come over here, and the base is 6 for both of them, so we do have the same base. So we are going to add the exponent. So we're going to say that's 6 to the negative 2 plus 5, and negative 2 plus 5 is 3, so that is 6 to the 3rd power. 6 to the 3rd power. Looking at number 2, or the next one, it says solve the following: 2 to the 3rd power divided by 2 to the negative 4th power. That is your division. And division said that we are going to subtract those exponents. So we would have 2 to the 3 minus negative 4. 3 minus negative 4 is the same thing as 3 plus positive 4. So that would give us 2 to the 7th power. And if we work that out, that's going to give us 128. Okay? Whereas in the previous problem, 6 to the 3rd power is 216. Forgot to work that one out. Okay, and now we have our power of a power. Power of a power, 4 squared to the negative first power. So we multiply those exponents, and we have 4 to the 2 times negative 1. Positive times a negative is a negative. So we get 4 to the negative second power. Remember, we take the reciprocal, make our power positive. 4 squared is 16, so this becomes 1/16. Okay? We will do more work on this in class, so it's okay if you're not understanding it right off the bat. So down at the bottom we have our table with example problems. The first one says example 2 to the 4th power plus 2 to, or times 2 to the 3rd power. This is your product rule. The bell is going to ring, just ignore it. Okay, so we expand this out. 2 times itself 4 times, 1, 2, 3, 4. So this is the first power. And then we have our other one that says 2 to the 3rd power, so we do 2 times 2 times 2, which is here. And because we're multiplying them, we multiply here. And if we count this, we have 7 2's that are being multiplied. So that gives us our 2 to the 7th power, which is 128. So this is just proving that product rule that says I can just add the exponents. So on number 1, we're going to do the same thing. 5 cubed times 5 squared. What are we going to get? So we're going to come over here and expand it. So we're going to say 5 3 times, 1, 2, 3, and then 5 twice, 1, 2, and they're being multiplied. So now I have 1, 2, 3, 4, 5 5s. So that's 5 to the 5th power. And if we work that out, 5 times 5 is 25, 25 times 5 times 5 times 5. So you can go ahead and in the space next to your notebook, you can work that out. And you should have got 3,125, okay, which is 5 to the 5th power. So now on the next one, when we do a negative exponent, what do we do with that? Do you remember? We are going to put it over 1, so we're going to take the reciprocal. So this is going to be 1 over 8 times 8 times 8. 8 times 8 is 24, 24 times 8 is 512. So in reduced form, this is 1 over 8 cubed, and that is 1 over 512. I hope you can see that. This tab's not in the way. Okay? On the next one, we have our quotient rule, 2 to the 5th divided by 2 to the 4th. So we are going to do, some reducing here. So for our quotient rule, on the top we have 2 to the 5th, so 2 times 2 times 2 times 2 times 2. And on the bottom, we have 2 to the 4th, 1, 2, 3, 4. Now, you know anything divided by itself reduces down to 1, so we're going to reduce these down. So we have 1's there, we have 1's there, 1's there, and 1's there, okay? And all that's left is 1, 2. So the answer would be 2 to the 1st power, which is going to just give you a 2. So 2 to the 1st power, and the answer would be 2, because we reduced everything except for 1 down. And if you subtracted 5 minus 4, you end up with 1. Okay? Last one, product of a product. So product rule, we have 2 to the 3rd, or 3 squared and then cubed. So 3 squared is 3 times 3, and then cubing it means doing that 3 times. So 3 times 3, 3 times. 1, 2, 3, which is going to give us 1, 2, 3, 4, 5, 6. So that's 3 to the 6th power, which is 729. Okay, and so tomorrow in class, we will do a lot more examples of this, and I'm going to put your practice problems on a PDF for you to do on your right-hand side.